Okay, so today what we are going to discuss is the basics of electronics and embedded system. Okay, so yesterday we have discussed about the basic concepts of electronics. Okay, I'm sure that that is not enough for you to build a robot, but I will say it's a guide or it's just a spark for you to start with electronics. Okay, we just gone through some basic concepts of electronics, and then I have shown you some components. Okay, like common components that we are using in electronic circuit. Okay, and I mean when we started we have discussed what is voltage, current, charge, all those stuff, which is very important. The concept of charge, voltage, current, resistance, all those are very important when we start working on circuits. Okay, so today what I'm trying to do is I will give an abstract overview of the things that we have discussed yesterday. Okay, maybe 5 minutes, 5 to 10 minutes maximum. Then we will be jumping into these topics. Okay, like what are the main components that we can use to build a robot. Okay, then we will be focusing on the brain of the robot. Okay, which is basically a computer. So there are different kinds of computer. We can say a microcontroller is a microcomputer. Then there are single board computer, there are full-fledged PC, laptop, everything can be used as a brain of the robot. Okay, so we will be seeing some boards, like maybe I can show you some idea. Like you may have seen Arduino. I'm not sure you have seen a board like this. It's called Tivasi Launchpad. Okay, then I have many boards this is Odroid. Jetson Nano. Okay, that is a single board computer, and there is another board, like there is Odroid. So we will be seeing all this stuff. Okay, I have taken some of the board that I have already. Okay, so we will be having a discussion about this. Okay, and how to program this, and how to connect a circuit from this board to the robot. Okay, yeah, so all these things we can see this session. Okay, so again we can start with the basic stuff. If you are not there in yesterday's session, maybe I can give an idea, like what are the basic concepts that we have discussed yesterday. Okay, so we have talked about charge, voltage, and current. That was the main thing that we have discussed initially. Okay, so I know heard about charges, right? So it's like charges exist. It's like a force. Okay, like gravity or something. It's exist actually, and there are two types of charges: positive and negative charge. Okay, so the thing is that the similar charges repel, opposite charges attract. Okay, that's how the charges work. Okay, so if there is a group of opposite charges, then there will be some forces existing, because the force for attraction, right? So we can make use of this force in order to drive something. For example, if we have this force, maybe we can use this force to drive a motor. Okay, drive an LED. Okay, so there are many use cases for this force. Okay, so the force existing between a positive and negative charge, we can call that force as a voltage. Okay, so that is the potential difference between these two opposite charges, positive and negative. So using this force, just a second, Rohan, can you just mute your mic? Yeah, thank you. So using this force, we can drive circuits. Okay, even we can drive a robot. So I'm not sure you have you know how the robot circuits work. Basically, most of the robotic circuits are powering by direct current. Okay, I'm not sure you heard about DC and AC, DC versus AC. The current or the current that is available in our home is alternating current. Okay, these all are like physics fundamentals. Okay, so this is actually we are having in our home 230 volt AC current, alternative current, but we have to convert into direct current in order to drive these electronics components. Okay, like mostly the electronics component in robots work on direct current. Okay, some of the components can be operated using AC. So mostly I'm saying the direct current is using in most of the circuit. So you can see the difference between AC and DC. Okay, so AC, the voltage is fluctuating. It's a sine wave. Okay, you can see the voltage is like fluctuating, but in the direct current we are getting the voltage constantly. Okay, so this is what we are using in the electronics circuit, even in computer, mobile phone, everything. Okay, so there is a conversion happening from AC to DC. So whenever we charge our mobile phone, what happening is that the mobile charger is converting the AC to DC and then charging the battery. Okay, then we can use it. Okay, I hope you understand the concept. Then yeah, so that is a voltage. It's a force actually. Okay, using that force we can even drive a complete robot. Okay, and the rate of flow of the charges is called the current. Okay, rate of flow means whenever there is a connection between the positive and negative charge, the charges will flow, right? Charges will flow and neutralize. That is what happening. So this rate is called the current. Okay, so the sources of the current, or to get voltage, we can use the batteries, or we can directly take it from our outlet, power outlet, and maybe convert to DC or something for our robot. Okay, yes, then we have discussed resistors, then Ohm's law. Okay, resistance, again I'm saying like the resistance is the resistors is like a electronic components. Maybe I can just show you a group of resistors. Yeah, here can you able to see? Maybe I can just put it. It's this is resistors. These resistors can limit the current flow. From the word itself you can understand resistor, right? It is resisting the current flow or like the charge flow. Okay, commonly this kind of resistors are called precision resistors. Precision. Okay, the difference is these resistors are blue, light blue, meaning it's a special category of resistors called precision resistors, and if there is no specific color for it, then that's a normal resistors. Okay, so and there is a color code for getting the resistance value. Okay, so you should read about it. Okay, at least you can just go through this, and we have seen how to create a circuit. Circuit simply means it's a flow of charges from maybe positive to negative. Okay, it's a completion of the circuit, like somehow the charges has to travel from positive to negative or negative to positive, whatever it is. Okay, so that completion is called a circuit. Okay, so in the circuit we can put anything to make use of this force called voltage. Okay, so imagine you are just connecting a motor. Okay, simple DC motor. Let me check. I have a motor with me. Yeah, I have a DC motor like this. Okay, so this is a simple DC motor. Let me open it for you. Yeah, so in order to drive, you may have seen these motors, like these can be found in toy cars. So in order to drive these motors, we can make use of this force called voltage, and then using that force you can rotate this motor. Okay, so when you connect these motors into a battery, you're creating a circuit basically, right? So that is actually called a circuit. It's like a completion of the charges basically. Okay, yes, so we have seen that. Yeah, so these are the main things that we have discussed, and then I have shown you some important thing when you important components when you start working with robots. Okay, so I will call it as an electronic workbench. Okay, so electronic workbench basically like it is having all the tools that we I mean we can able to prototype using the workbench. Okay, personally I don't have a workbench, but currently I'm putting all this stuff on my table. Okay, I mean computer table for the demonstration, but this is like a electronic workbench. You can see the lot of tools. Then even you can find all the necessary tools, even pliers, then multimeters, everything is there. Okay, so if you want to create a robot, at least you should make a small version of this. Okay, because you may need it. Okay, you may need to use almost all the things mentioned here, like but you may have to create a like economic version, what I will say, of this. Okay, in order to build a robot. Okay, this is actually very nicely organized, but in reality it will not be, because when we start working it will be messy for sure. Yeah, so so in order to start prototyping a robot, basically it will be good to have a breadboard. I mentioned I have shown the breadboard yesterday, right? So the breadboard basically just a sec. Okay, so the breadboard basically a prototyping board in which you can plug the components, electronics components like resistors, capacitors, anything on this board, and then you can create a circuit. Okay, and you can unplug it at any time. Okay, so it will be good to have a breadboard. Okay, and if you're starting with electronics, I will prefer you to buy a multimeter. Okay, a multimeter. This is a very cheap multimeter. Okay, very cheap. I think around 200 rupees. You will get it. Okay, so what is multimeter? Multimeter will be a very useful tool for you. It is for measuring the voltage and current, and also the resistance. Okay, and also the continuity. I mean there are different functionalities in a multimeter. It's depend on the like quality of it. So currently what I have is a very basic version. I will say very basic multimeter. Just a sec. Yeah, I think now it will be. Yeah, so this is a digital multimeter. When I started with electronics, there was an analog multimeter as well. I'm not sure it is available now. So you can see there is a provision for measuring direct current. That is what indicated here, V, and there is a straight line. Okay, that means direct current, and then V, and there is a sine wave, which is alternating current. Okay, and then you can see here A, that is for measuring the current. Okay, then there is a diode symbol. This is for checking the continuity, and there is a option to check the transistors. Okay, then there is an option to measure the resistance. For example, if I want to measure the resistance, okay, of this resistor, what I can do is I can just switch on the multimeter, then just put like one measurement, 20K. Okay, 20K is the resistance that I put. Okay, that means the multimeter can detect up to 20K resistor. So I can just use these two terminals, positive and negative, and then I'm just using this terminal to just placing the resistors in between, and then I'm just placing like this. Okay, so you can see a resistance value there. Maybe I can just reduce the resistance, that is 2000. Now let's see what it is measuring. Yeah, it's around 1K. Okay, so it's around 1K or 1 kilo ohm. Okay, so that is the advantage of having a multimeter. You can quickly find out resistors, then current, voltage, everything. Okay, so this is one of the standard multimeter from Fluke, which is very standard and accurate. Okay, so I mean, it depends on your budget. You can buy a multimeter. Then if you're using battery, okay, battery, then there are battery holders, okay, that you will get it. Maybe I can show you a battery holder from my robot. It's very simple, like just a sec. Yeah, you can see, right? So you can put the battery here, and then you can take the, I mean, this is actually, the batteries are connected serially, meaning the voltage will be adding up. Okay, but if we are connecting the battery in parallel, the current, we will get more current flow, okay, with same voltage. Like the individual battery voltage is 1.5 volt. Okay, so if we are connecting serially in this manner, it will be adding up. So totally the voltage is 4.5. Okay, so if I'm adding one more battery, then totally 6 volt I will get with the limited current. Okay, but if I am connecting all the cells parallelly, then I will get more current flow. Okay, so I will suggest you to read more about this. Okay, but I'm just going through the basics. Okay, yes, so, and if you want to connect different you should need this wire cutter. In order to prototype the circuit, you may need wire cutter, then screwdriver, then like if you are soldering, I think yesterday I have discussed about the soldering, so you may need the soldering. I'm not sure you need this, but sometime. Then if you are planning for the prototyping, the jumper wires will be super helpful. Okay, then the soldering iron. Okay, I think you have seen the circuits yesterday, right? In order to create a PCB, a circuit like this, okay, in order to connect or put the sensors or components, you may need a PCB and you need a soldering iron to solder the component on the PCB. Okay, yes. So yes, that's it. So these are the things that we have discussed. Then these are the components that we have seen: diode, LED, transistors, relay, IC. Okay, then circuits, these are the schematic. Okay, I hope it's clear to you. Then Ohm's law we have seen, computing resistance. This is a simple circuit with a resistor. Yes, so these are the things that we have discussed yesterday. So today, what I am trying to show you is the first one. What are the basic electronics components to build a robot? Okay, build a robot. So I am assuming maybe I'm planning to build a simple robot. We can call it as a differential drive robot. Okay, differential drive robot simply means there are two wheels. Okay, there are two wheels, and there is a left and right wheel. Okay, and using this left and right wheel, it can drive. Okay, so what I'm doing is I'm opening one of my book called Rose for Absolute Beginners. Okay, let me check the page. Maybe I can use that book for the reference. Yes, here is the book. Okay, so I can show you the robot that I am mentioning. Okay, let me check. Yes, this one. Okay, so this is the robot, okay, that I am talking about. Okay, this is a very basic robot. That's why I am like taking it. Okay, it's not very complicated. You can see there is a left and right wheel. Okay, and then on the wheels you can see there is a motor. Okay, there is a motor, and if you power this motor, this wheel will rotate. Okay, maybe I can also show the robot circuit here. It's pretty messy, but I think it will be better to show you the circuit. You can see here, right? So this is the bottom view. You can see the motor, and there is a gear. It's actually like a motor with some gears, and it's coupled into the wheel. Okay, so the top view will be like this. Yesterday I have shown that to you. Oh, just a sec. And you can see all the wires. It's very I mean messy here. Oh, let me just try to rise the tripod. Oh yeah, almost look like this. Okay, and you can see the battery holder, and there are some circuits, right? So that's what I'm trying to explain. So in order to create a basic robot, okay, so currently what I am trying to show you is a mobile robot, a robot that can move. Okay, there are different kinds of robot. Okay, for example, you may have seen a robotic arm like this. Okay, so this is another category of robots. Okay, again, all this robot is having motors, and mainly there will be actuation, mechanical actuation using motors. Okay, so the main components of mobile robots will be actuators or motors. Okay, so in our case, the example, we are trying to create a wheeled mobile robot, and this robot is called differential drive robot because there is a left and right wheel. Okay, and if the two wheels are moving at the same speed, okay, then the robot will move forward. Okay, and if the two wheels are moving in the opposite direction or backwards, I mean same speed but anti-clockwise or something, yeah, anti-clockwise, then it will move backwards. Then if the two wheels are rotating in opposite direction, it will rotate. Okay, you can imagine like adjusting the speed of the wheels, we can control the direction of the robot. Okay, so like if the two motors are running at the same speed, it will go straight or back or front, and in order to rotate, we have to change the speed of one wheel. Okay, then it will rotate. Okay, so that's how the differential drive robot works. Okay, so in order to make a simple differential drive robot, what are the components that we need? Okay, that's what we are trying to explain. So the main components for this robot is two motors, obviously. Okay, so you have seen that motors, right? And then wheels, and in order to power these motors, okay, in order to drive this motor, obviously we need some source of some voltage source, right? So here we have a battery source, battery holder, and then we can put the battery. Okay, then we have the voltage source. This is the voltage source. Okay, and then in order to adjust the speed of the robot, or like if we want to move the motors in one direction or opposite direction, or reduce the speed, what we can do, like currently we only have the voltage source and motors. Okay, so what will be the circuit that we have to use in order to control the motor speed and direction? Can anyone say like what we have to use for controlling? If you have any experience with robot building, you can say like what will be the circuit we have to use in order to control these motors. I mean, the main purpose is controlling the speed and controlling the direction. Can anyone say, or anyone know about it? Anyone? Yeah, so Jasnia is saying it's motor driver, right? Yeah, I think some of you are already know. Karthik and Hari, yeah, I think you know. Exactly. So the circuit that we have to use in order to control the motors in a robot is called motor driver. Okay, motor driver. So Just a second, just a second. Okay, so we discussed about the motor driver, right? So that is a circuit. Okay, it's an electronic circuit and it is having some components. The main purpose of that circuit is controlling the speed of the motors. Okay, so is that enough to drive or control a robot? Is that enough? Do we need any other circuit or component or anything to control or drive the robot? For example, we need to control this robot using our mobile phone. Okay, mobile phone. Are you seeing? I mean, do we need any more components for building this robot? I mean, a robot that can be controlled from a mobile phone. Okay, so Jisnia is again a microcontroller. Okay, so Karthik saying like specifically Arduino. Yeah, it's a microcontroller platform. Yes, so I agree. We may need some decision making circuit. Okay, or we can say the brain of the robot. Right? We may need a brain for the robot in order to take decision. Right? So yeah, so we got that, like we need motor driver, then we need a microcontroller. Okay, microcontroller is an integrated circuit, okay, in which we can program it. Okay, we can program an integrated circuit. Okay, programming means the programming of microcontroller means I think you know about the integrated circuit, right? Integrated circuit, which is basically components which is having many pins left on the left and right. Maybe I can show you that. So this is actually an integrated circuit. Okay, like you may can see all these kind of components in any electronic circuit. Okay, so there are many pins, right? Many pins on the left and right, or if it is a this kind of package, then the pins will be all around the chip. Okay, so programming a microcontroller means we can independently control each pins of the microcontroller. Okay, for example, if you want to set the voltage of this pin into 5 volt, okay, you can program it. Okay, if you want to set the voltage into 0, you can program it. Or if you want to set the voltage means here the voltage is direct current or DC. Okay, so if you want to like set the voltage to 5 and then 0 with a 1 second delay, you can do that. Okay, in a sense you can control this chip entirely. You can control all the functionality or all the pins of this chip, which is actually a great thing. I'm not sure how many of you thought about the possibilities. I mean, the possibilities are infinite. Just think you have a microcontroller and just think what are the possibilities that we can do with this. It's infinite, I will say. Okay, when I was like introduced with the microcontroller, I was totally amazed because the range of applications that we can do with this thing is infinite with this single chip. So what, think about a computer, full-fledged computer. Okay, we can like program it, and that's the power of the computer. Okay, even you can program a robot using a computer. I mean, it's literally controlling the world. Right? So like we can do a lot of things. Okay, that's how the computers like got this much of attention. Okay, so in case of microcontroller, it's actually an integrated circuit, meaning there is a circuit inside and you can program the circuit using, I mean, C, C++ or any programming language, and then you can independently control these pins. Okay, which is actually amazing, right? Yes. So so we know we need to use a microcontroller. So I mentioned the application. We need to communicate to the robot from a smartphone. Okay, so there should be some component for communication, right? So what should be the component that we can use to communicate from a smartphone? Anyone? Anyone know? Yes. So Jarin commented, and anyone know? I think Jisnia is also like commenting. Yeah, Bluetooth. Yeah. So Jarin and Jisnia, you are right. You should have a communication component like Wi-Fi or Bluetooth we can use in order to connect the robot to the smartphone. Okay, so now you got a picture, right? We need following components. Okay, so if you are not aware of electronics, I will say electronics is again like a logical thing. Okay, logical thing. If you have some kind of common sense, we can just, I mean, you can easily create a robot by simply following a tutorial or something. So you don't need to be a electronics enthusiast or electronics uh, expert or something, but you can simply find these components and it's just a matter of connecting these wires and all. Okay, if you are following a tutorial, you can simply make it. So no need to feel that like you are from mechanical or you are from some other background and you don't know electronics. That is pretty fine. Okay, you can simply learn this by following tutorials. Okay, so I'm showing a motor driver circuit. So this is a typical motor driver circuit called L298. Okay, I can show you that. Yeah, so this is the circuit. You can show, you can see the circuit here. Okay, so it's like it is having a chip. Then there are many components. Okay, and this circuit is a modular circuit. Modular means the entire H bridge, the motor driver circuit is packaged into a PCB. Okay, so this is a PCB. You can see the connection here. Okay, you can see the connection here, right? So this is a modular circuit, and the purpose of this circuit is controlling the motors. Okay, and you can find the connections, okay, on left and right. Sorry for the blurring. Yeah, on the left, right, and there are, you can see these pins, right? You can see this connection. So this is for, maybe I can use this one. This is for one motor, this is for another motor, and this goes to yeah, mostly I think, just a sec. Yeah, so this is for one motor, this is for another motor. This is a supply, power supply to the motor driver. Okay, and then these wires will go to the microcontrollers. Okay, so what is the purpose? Like, in order to send commands to the motor driver, okay, like whether we have to go forward or go backward, or like reduce the speed or rotate clockwise. So all these commands are sending by the microcontroller. Okay, so that is these wires. Got it? So the motor driver simply controls the motors. Okay, but who is controlling the motor driver is the microcontroller platform. Okay, and the microcontroller platform, you can see here I am using a microcontroller platform called Arduino Mega. Again, a lot of wires, sorry for that. Arduino Mega. You can see a chip here, right? This is a chip, and the chip pins are like taken out using these things. Okay, So it's called Arduino Mega. It is having more pins. Okay, or I can show you the Arduino board separately. Just a sec. This is one of the basic boards that you can buy called Arduino Uno. If you are like very beginner in microcontroller or something, you can easily buy this. I think 300 or 400 rupees for this board. Okay, so you can find a microcontroller. Okay, there is a name for that. It's Atmel. I think, yeah, 328. I forgot that. 80 Mega 328. Okay, and you can see the pins of it. The microcontroller pins are like, we can access these pins from these slots. Okay, so this is the brain of robot. Okay, one of the brain. Okay, so if you want to play with simple robots, I think you can do that using these kind of microcontroller platforms. Okay, so the microcontroller platform simply having a microcontroller, then there are some ports. Okay, ports means connections. So in order to program to this microcontroller platform, there is an USB connection to the computer. Then you can power this microcontroller platform using a DC jack. Okay, you can provide 9V to this DC jack. Also, it can powered using USB power. I'm not sure you have, I mean, you know, the USB can deliver power, right? 5V with 600 milliampere it can deliver. So using that power, this board can perform. I mean, board will work. Okay, so basically using this board we can program this. Using this board you can connect to the computer and program this chip. Okay, simple, right? So that's how the robot, the entire circuit of the robot work. Okay, I missed one component that I can explain, and the Bluetooth is what I am using here. And if you want to add like more sensors to the robot, for example, if you want to detect obstacles on the robot, we can use an ultrasonic distance sensors. Okay, and if you want to compute the speed of the rotation of the wheels, we can use encoders. Okay, it's specifically called wheel encoders. Okay, so there are two types of wheel encoders: optical encoders, magnetic encoders. I mean, not two, but these are the main category. And then this is the block diagram. Okay, so if you are not not an electronics guy, and if you are seeing this diagram, I'm sure that you will understand something. Okay, there are some connections are missing, and that is updated in the next version, but I think mostly the connections, I think you can decode it, right? You can find it. Like there is a 9V source or 6V source, whatever. That is the battery holder. From the battery holder, we are powering the motor driver. Okay, so the motor driver can control two motors, M1 and M2. Okay, the name of the motor driver is L298. Okay, so you will get all the information of L298 from Google. Simply just search. You can find L298 board. It costs around 100. Yeah, so this is a board. Okay, and then we have seen the motor connection. Then these are the microcontroller connections. I mentioned that the motor driver is connected to the microcontroller. Okay, in order to like completely control the motor driver. So we can rotate the motor in any direction. Okay, so in order to rotate these motors, we have to give commands from the microcontroller. Okay, commands in the sense these all are simple pins. Okay, we have to set these pins as high or low. High means maybe 5 voltage, low means it's 0 voltage. Okay, So according to these pins, for example, if you are setting the ENA enable pin of ENA pin high, then the first motor will be activated. Okay, then only the motor will work. Okay, if you set the ENA pin as 0, then M1 will be stopped, or the motor 1 will be stopped. If we set ENB as high, then M2 will be started. Okay, M2 will be activated. Okay, and these IN pins enable these IN pins are controlling the direction of the motors, okay, clockwise and anti-clockwise. Okay, and this enable pin, if we can provide a pulse, okay, pulse, I think you know what is a pulse is. Maybe I can show you that pulse. Yeah, you know what is a pulse, right? Basic physics, like pulse means it's like a square wave or something. You can say square or pulse. Basically, pulse, like it will go to high for some time, then low sometime, then high, high low. Okay, so if you are constantly switching these motors, okay, if you are like fully on the enable pin, then the motors will rotate in full speed. But if you keep on switching on and switching off this pin, then we can control the speed of the motors. Okay, so by providing a switch on and switch off, or giving a pulse to the enable pin, we can control the speed. And by changing the IN1, IN2 or IN3, IN4, the pin, like if we set 1 and 0, it may be rotating in clockwise, or 0 and 1, it will be 0 means 0, 1 means I am saying 5 volt, okay, high or low. I'm talking in binary. So yeah, so that's what the H-bridge circuit, or the motor driver. It's also called H-bridge actually. So you will get what is H-bridge from Google. It's basically a circuit, motor driver circuit. Okay, and then we have the microcontroller, right? So in the microcontroller, you can see a Bluetooth module is interfaced. Okay, Bluetooth module. So in Bluetooth module, basically we have a transmit and receive pin. Okay, so you can just connect it. Okay, it's not a big deal. You have to power the Bluetooth module, we have to power Arduino Mega, and just connect these pins. Okay, so 19th pin should be connected to the TX, and 18th pin connect to the RX. Simple. Okay, then if you want to detect distance, obstacles, then connect an ultrasonic to a specific pin, and then we have to program it. Okay, and also if you want to connect an encoder, you can connect to it. So this is I'm showing this connection because I programmed the microcontroller based on these connections. Okay, so this is a schematic or block diagram of this robot. If you have any doubts, you can ask me, because these all I'm thinking that these all are very basic things. Okay, so this is a block diagram, and this is a messy circuit. You can see a lot of wires because I was too busy to write this book and create the robot. So this was a situation. Okay, this is a reality. Okay, and you can find the microcontroller, motor driver, Bluetooth here, ultrasonic, battery. For this I was using a 9-volt battery. Okay, so this is a robot circuit. Okay, then I have programmed the microcontroller and then interface to ROS, all those stuff. Okay, so I think if you have any doubts regarding building a basic robot circuit, you can ask me. Okay, you can ask me now. It's very logical. It's not a big deal, I will say. You can find lot of tutorial from web, and if you know the basic components, you can buy it and just follow the data sheet or something and connect it. It will work. Okay, and after connecting you have to program the Arduino um, microcontroller platform. Okay, so guys, do you have any doubts? You can ask me now, and then I will be going to the next topic, which is uh, the introduction to IO boards, introduction to SPC. Okay, it will not take much time, it's just familiarization. Let me know if you have any questions regarding the electronics components for building a robot. Basically, we have to select motors, then we have to select maybe motor driver. Okay, there are different kinds of motors, and I actually wrote a blog regarding that, so that will be super useful. I will be mentioning that. Yeah, so that's how we can build a simple robot. Okay, if you are planning to build a line follow robot, for example, you have to find the proper sensor for it, and then you have to find a motor driver. Mostly it will work with L298. Then you have to choose a microcontroller platform, maybe Arduino. Okay, yes. So I hope it is clear to you. It's not a big deal. Now it's just the familiarization of some IO boards and single board computers. Okay, so before that, I just want to show you how the Arduino boards are getting programmed. Like there is a, if you just go to Google and search for Arduino, okay, you will directly go to the website, and you can find a software which is we are using for programming Arduino. Okay, so you can download the version for the operating system. So if you are using Windows, you can download, or Linux, you can download it. Okay, so currently I'm in Windows, and you can see this is the software. Okay, and this is how the program looks like. Maybe I can show you a basic program, maybe a blinking program. Okay, blinking program. Okay, and its circuit. So just to get an idea, Arduino LED blink. Yeah, and you can able to see the circuit as well. Okay, so they already mentioning, like if you are like seeing this kind of project, you can see what are the components. So Arduino Uno, a breadboard, a LED, jumper wire, a resistor. Okay, okay, then Arduino IDE, then they provided the code and then the circuit. Okay, so this is a circuit. Let me download it, and then let me open it. So can you able to see the circuit? Right, you can see, right? So here you can see there is an LED. Okay, there is an LED, and you can see this terminal, okay, this is positive, okay, for the LED, and this is negative. Okay, so and this is a resistor, and the whole thing is a breadboard. Okay, so here Arduino pin are acting as a voltage source. Okay, so like there is a pin called 13. So if you switch on or set 1 or set high this pin, okay, then we will get 5 volt here. Okay, so 5 volt here, and this blue color is actually ground. Okay, or you can say it's a negative. Okay, so ground, and this black wire will turn 5 volt. Okay, so whenever it turn 5 volt, it will be like there is a resistor in order to control the current flow, and there is an LED. Okay, so if you check the program of the Arduino, it's again very easy to program. Arduino is very easy to program. What we are doing is we are like setting the pin of Arduino, that is the 13th pin, as output. Okay, output means we can set that pin as high or low. Okay, and then in the loop, meaning this section is doing repeatedly. the Arduino is power off. Okay, so you can see we are writing a high value to 13. Then after 1 minute or 1 second, we are setting as low. Then after 1 second, it will setting as high. So what will be the output of this circuit? What will be the output? I mean, this program is like, it's very easy to read, right? Easy to decode. So basically, this pin will set high, that is 5 volt for 1 second, then set low, that is 0 for 1 second. So the LED will blink. Okay, that is the output of the circuit. Okay, so if you learn Arduino programming, you can easily build robots, simple robots. Okay, and the programming is not difficult, it's very basic. You can do it using tutorials, and it's not a big deal, I will say, okay, for beginners as well. So if you are not having Arduino knowledge, just grab a board. Okay, it will be very useful if you are like planning to work with robots. Okay, I will recommend this board. Okay, and you can start programming. Okay, so let's have a familiarization of some of the IO boards and single board computers. Okay, just a familiarization. So first I can start with Arduino. I think you already know what is an Arduino is. Just a sec, let me switch on the light. Okay, so you can able to see the Arduino board we already explained, right? So there are many variants of this board. This is very basic. If you just go to the Arduino website, you can find hardware. Okay, and you can able to find different boards. I mean, there are many boards. Okay, so there are many variants with different microcontrollers, different circuit. Okay, everything is available. Okay, so you can choose according to your application. Then I just want to introduce another microcontroller called Tivasi Launchpad. Okay, so this is Tivasi, the red guy. So again, this microcontroller is again very popular. Okay, I'm not sure you have heard about it, but it's actually very popular. You can program this microcontroller. You can see the pins here. Maybe I can show you the side view, and on the bottom you can also like access the microcontroller pins here. Okay, so the Tivasi board you can program like Arduino. Okay, so if you just go to Energia IDE. So Energia is a software. Okay, it's actually adapted from Arduino IDE or Arduino software, and you can program these kind of board, Tivasi Launchpad, all this board using Energia. Okay, so I think they actually mention what are the boards support by Energia. I think most of the Tivasi Launchpad, Tivasi boards will support Energia. Okay, so yeah, so that is another board called Tivasi. And why we are using it? Because it is very cheap and more powerful than Arduino. Okay, so in your computer, you may know the CPU speed of the computer, right? CPU clock actually. Like you may have seen 2.5 gigahertz or 3 gigahertz, 2 gigahertz, right? So similar to that, the microcontroller is also having a speed. Okay, for Arduino, mostly Arduino are like working in 16 megahertz, 16 megahertz. Okay, not gigahertz, 16 megahertz. And newly microcontrollers, newly Arduino boards are like maybe work in 50 megahertz or 80 megahertz, 80. But this microcontroller called Tivasi. It's working on 80 megahertz, 80, and it's cost around less than 1000 rupees. Okay, but if we buy from here, it may be slightly higher, maybe 1000 to 1500. Okay, but it is running on 80 megahertz, so it's more faster. Okay, for so in some cases, if you want more powerful boards, IO boards, we can go for it, and it's cheap as well. Okay, you can buy it from India for sure. Okay, yes, so those are the two IO boards that I have. I had Teensy as well, but Teensy is another microcontroller, but I'm not sure where it is. Maybe I can start introducing the single board computers. Very famous Raspberry Pi. Ignore the background, just look at the board. So I'm sure that some of you have heard about the Raspberry Pi board, right? Maybe I can just rotate it. Raspberry Pi board. Okay, so what is a Raspberry Pi board? What is a Raspberry Pi board? It's a single board computer, or a computer within a small form factor. Just check, this is this much length. Maybe I can just compare the length of Raspberry Pi with my finger. Okay, you can just check this much length and this much width. Okay, and what is this board offering to us? The board is offering a lot of things. It's a computer, and you can run a complete operating system, a full operating system like Linux, Ubuntu, Linux variant operating system, and also Windows. Not the desktop version, but I think a version, IoT version of Windows, Linux, you can run on it. Just imagine you have a very small computer and you can run an operating system. So it's a computer actually. Okay, you can find the display port, the HDMI port, then speaker, then USB here on the front. Okay, there is Ethernet port. This is actually an old version. Okay, but you can find what are the things that you can most of the things that we can see in a computer. And also, if you want to communicate through like in Arduino, we have seen pins, right? Pins, input output pins. So Raspberry Pi is having input output pins. So you can write a Python program from a Linux and you can set these pins high and low. Okay, just imagine the application, again infinite, right? So you can build a robot using it. You can connect a camera. Okay, you can connect a type of camera here, or you can connect a USB camera here. Okay, so if you want to run ROS or something, you can buy a Raspberry Pi, maybe the latest version, Raspberry Pi 4, and then install Ubuntu, and then put, all the things are installing on an SD card. Okay, here there is an SD card. You can put everything on an SD card and then install ROS and work with it. Okay, amazing, right? So I just want to show you the website. You can just search it. You will get the Raspberry Pi website. Okay, this is the official website of Raspberry Pi, and you can find different Raspberry Pi models. There is a mini version called Raspberry Pi 0. Then the latest version is full-fledged version is Raspberry Pi 4. Okay. Oh, I forgot to take the Pico as well. That is again a microcontroller from Raspberry Pi Foundation. So this is Raspberry Pi Pico, which is a microcontroller platform. Okay, cost around 300 rupees. working in 120 megahertz or something. Like, let me check. Yeah, it's working in 180 megahertz or something. Okay, it's a $4 microcontroller platform. Just imagine, the cost is very cheap, and you can easily program this microcontroller using Python. Okay, there is a version called MicroPython. That is what you are seeing here. So it's very easy now. I mean, electronics is very easy now. There is no not much difficulty to get program using this microcontroller platform. Okay, so Raspberry Pi Pico is the microcontroller, and this is the full-fledged Raspberry Pi single board computer. Okay, and the latest Raspberry Pi, it's more powerful. You can get even up to 8 GB of RAM, then a good CPU, I think more than 1.8 gigahertz. Okay, you can see for a 4K output. Then you can simply use it as a computer, full-fledged computer. Okay, just check the tech specs. It's amazing, right? You can see yeah, the processor, RAM, Ethernet, USB 3, USB 2. Okay, all these things. Maybe I can just share the specification, and the cost is also not very high. Okay, that is a main attraction. Okay, it's very affordable, and you can install Linux, and you can install ROS. Okay, yes, so these are the things. The Raspberry Pi which is this, not sure you can able to see this. Yeah, so you can find a chip here, right? So chip, and this is a RAM. Okay, so this chip is called SoC, system on chip. Okay, so this kind of board, I mean this kind of SoC can be found in our mobile phone as well. Okay, SoC means the chip is having processor, then GPU, and maybe RAM in a single chip. Okay, so that is Raspberry Pi. Now I'm getting into another board. Let me change the board. I'm not sure you have heard about this board called Odroid. Okay, let me switch on the lights. Odroid. Okay, Odroid is again a good single board computer. Okay, I bought it actually for a robotics application, and it's very similar to Raspberry Pi. Just check the website, Odroid website. They have also like I mean some variants of Odroid, and you can run Ubuntu on it. Okay, so there are many variants of Odroid. There are powerful ones, and with fan and all. So Odroid is having a better spec in some boards, but nowadays I will say Raspberry Pi is better, because Raspberry Pi is cost effective and support. Then the spec is also amazing. Okay, so I just want to show you the Odroid board. Not a big deal. You can see these all are like thermal heatsink actually. Okay, so underneath there is a chip. Okay, similar to Raspberry Pi, there is a USB port, Ethernet port. Okay, then on below you can see this microcontroller, I mean micro SD card. Okay, and also you can add like eMMC. Okay, so there are many add-ons. Okay, this is Odroid. Now the latest one, that is the last one in our case. I just want to show you one of the popular board, which is called Jetson Nano. Okay, so this is Jetson Nano, and why it is popular and why we are using it. Is it better than Raspberry Pi? I can answer it. So first, just go to the website. Okay, so Jetson Nano, it's from NVIDIA. Okay, so you can imagine NVIDIA is a pioneer in graphics card. Okay, so Jetson Nano having something related to the graphics. Okay, so NVIDIA is presenting some good SoC, system on chip, okay, which is having some impressive specs. Okay, like it is having quad-core ARM processor, then it is having a GPU, good GPU with CUDA core. CUDA means it's a framework created by NVIDIA to program GPU. Okay, specifically NVIDIA GPU. Okay, so if you are planning to work with some computer vision application or deep learning, then Jetson Nano board will be apt for that. Okay, not very heavy board, not very heavy application, but small application. Okay, so in that scenario, Jetson is having an edge over Raspberry Pi. But even in Raspberry Pi, we can run most of the things. But in Jetson Nano, we can use the GPU, graphics processing unit. Okay, and you can program it using CUDA. Okay, so there are some other boards from NVIDIA, that is Jetson TX2, which is more powerful than Nano. Okay, than Jetson Xavier. Okay, which is again more powerful and more expensive. Okay, so if you are planning for like very graphics intensive or deep learning programs, I think these kind of modules will be very useful to you. Okay, Jetson Xavier is Jetson Xavier NX. I think it's the latest add-on, which is having 16 GB of RAM and very powerful. Okay, but expensive as well. Okay, so these are some of the boards that I have to show to you. Okay, I think that's it. So if you have any comments related to the single board computer or microcontroller or anything, you can put it in the Discord channel. Okay, I hope this session will be like a refreshing for some of you, or like it may help you to create an understanding of like microcontroller and microprocessor board. Okay, so now it's a Q&A session. Let me know if you have any question related to the today's topic. Okay, let me know. I will be update the last day session. I was just traveling, so I couldn't able to put that. So let me know if you have any questions. Any question, guys? Anyone? Any questions? It's clear, right? Any questions? Okay. So I'm assuming that it's clear to you. Okay. If you have any doubts, you can ping me on Discord. I mean, you can put it on the RDLP discussion channel. Okay, Rajesh and Jarin will support you, and also if I'm available, I will support you for sure. Okay, so these all are basic stuff. Okay, so thanks for listening. I think we can see you next week. Okay, we are not doing the project meeting tomorrow. I mean, there is a project meeting on Monday, like 20 minutes, but we are not doing that because we are not reached up to that level. Okay, so if you want to start project independently, then you can ping me. I can give a basic guidance, but I just want to like go through these basics, then only I'm planning to start the project meeting, so that you can you can think of a project idea and start working on it. Okay. Yes. So thanks for listening, guys. We can see you on next week, next Friday. So the next topic, I think, we can start with Ubuntu basics. Okay. Linux basics. Okay, Linux basic, which is one of the prerequisites to start with ROS. Okay. So we will be seeing the the features, different features of Linux that is useful for robotics. Okay, so I'm like focusing on the robotics actually, robotics side. So I will be like discussing on the IDE, then libraries, how to set up Linux, all those stuff. Okay, on the next session. Okay. Okay then, guys. Good night, and see you on next week.
Thank you, sir.
Okay.